Alright, so these are the pieces that we cleaned off previously. So as you remember, you want to remove all the mill scale, all the nitrided edges left from the plasma cutting. So what I wanted to show you here is something very important for TIG welding, which is jigging. Jigging is the setup you use to align and put your parts together. So what you have here, I've got a large metal block, and this could be anything. It could be wood, it could be anything at all. Alright, it's really just about size. So in this case I have this large metal block here, and then there's a plate over here, a copper plate, which gives me an edge here and here where all these pieces can touch onto. Okay, now if you remember going back to earlier in the course where we're looking at prints, okay, and we're talking about datum surfaces, okay, what I'm doing here is I'm establishing a datum surface, okay. A would be this one. So both of these pieces, this is the datum edge for this side of the cube, okay? Datum A, okay? And you could, the other datums would be here and here. So let's say B and C, okay? Which establish these other two sides of the cube. So reality, I have here three sides of the cube, 1, 2, and 3. I've aligned the edge right over here, okay, very carefully, and in order to meet the right size, this stainless plate under here, which you see, I actually have that stainless plate there because it just happens to be exactly the right thickness so that this is flush with the top of the cube. Okay, this is flush right here, which means when I bring this edge in, right there, I have a perfect 1F, okay, outside corner weld right there. And I put something on top just to weigh it in place. Now it's not going to move, so now I can leisurely tack this in place without any worries that it's going to get out of shape, and it's exactly 90 degrees. So if I start here, I know I have a good beginning. Okay, the beginning of the cube is really the most critical. You have to establish a reference corner, that one right here, okay, 90, 90, 90, a perfect reference corner. From that point, everything else will branch out from. If you mess this one up, it's just not going to go together. So take your time. Jigging setup can be very time consuming because you can be hunting all over the shop looking for exactly the right thickness of metal, size block. I've used index cards, even gum wrappers, okay, for shimming stuff when I had to, because it just happened to be the right thickness. They can take a long time scrounging around to find the right things. I always keep a lot of metal blocks around and plates exactly for this purpose. You may notice that's why I've got the bucket of aluminum pieces in the shop. That's what these are for. Now, a secondary benefit of using blocks like this is that all of these are massive heat sinks. Okay, remember we're working 1/16 inch steel here, very, very, very thin, easy to blow through. Okay, so by using these metal blocks for jigging, these are going to suck away heat from the joint, letting me hit this really hard and fast, getting a really good fusion without worrying that it's going to blow through. Now, the copper plate here is really your ideal material. If you have large copper blocks to use, that will ensure that in no way will this, if it happens to burn through, it's not going to weld itself to the surface, okay, if you're ham-fisted. But finding a copper block of this size, good luck. Usually plates, bus bars like this are more common. If you could just put them on top of this. So this is the jigging. When you want to tack this, okay, I would recommend do not tack exactly at the point, okay? Tack in about 1/4 of an inch in from the edge. If you try and tack on the edge, what's going to happen is this whole thing is just going to melt away on you, leaving a big hole, because the heat has nowhere to go. If you tack a little bit back from the edge, you still have material on both sides of your tack weld to absorb that extra heat and not blow away. So tack in a little bit, tack in a little bit. Then when you actually go to weld your corners together, you can carefully work into the point. Okay, keep in mind that as you're welding, the heat has to go somewhere. The closer you get to an edge, the less area there is for heat. Some of you who have worked during doing the vertical 3F probably noticed that when you reach the top of your plate that suddenly your metal just evaporated. That's because the heat doesn't know where to go. It's trapped, it builds up, and the minute you hit it with your arc, it just liquefies and goes all over the place. So as you're welding a cube, be aware that your corners are going to concentrate heat. So be very mindful of how you weld them. You have to be very judicious in your use of temperature control here. Don't just blast through the whole thing in one shot. You may want to weld a ½ inch at a time. Let it cool, continue, let it cool. There's no reason you have to rush through it. So this is the setup. I'm going to start. I'm going to set up and start tacking, so what it looks like, and we'll keep the build going.